Hi everyone! In this series we'll be looking at procedurally generating planets in a similar way to what Sebastian Lag did in his excellent Unity tutorial. But in my case I wanted to do it in Godot, so I decided to take Lag's tutorial and port it to Godot, and I'm going to show you how I did that. Now the first step is going to be creating a sphere, but not all spheres are created equal. A very nice trick that Lag used in his tutorial to have good control over the resolution of the planet while at the same time avoiding issues with texturing is to start with a cube and then expand this cube, basically inflate it and project the vertices onto a sphere. And the way it's going to work is something a little bit like this, where we have a cube here that's subdivided, and now we're going to take each of the vertices and project it onto a sphere, kind of like this. And as you can see, it becomes a very nice round ball, and this ball has very evenly distributed vertices, which is important when you want to do texturing. Now the first step, of course, is going to be creating our new project. So we'll start by creating a new project that I'm going to call BCG Planet YouTube. And we're going to create a folder and then start the editor. Now for our planet, what we're going to do is create a 3D scene. And the root here is going to be the center of our planet. So we'll call this planet and save the scene. Now we want to generate dynamically the mesh that's going to represent our planet. And like I said, we're going to generate it as a cube originally. So what we're going to do is we're going to have a separate mesh for each of the faces of our planet. So we can start by adding a mesh instance as a node, and this mesh instance is going to represent one of the faces of our planet. But before we do that, we are going to start creating some of the scripts we're going to need. The first one, we're going to create a script at the planet level. This is going to be the configuration for our planet. So we're going to just create a new script and call it planet. And we can for now just get rid of the comments. Next, we're going to create a script for our mesh instance, and this one we're going to actually call it planet mesh face. And again, we can get rid of this. Now on this planet mesh face, what we're going to need is a few properties. The first one is going to be exporting a var normal, and that's going to be a vector3. And this variable is going to specify which face we want to render by specifying where its direction is pointing. And next, we can add a function for regenerating the mesh. And we're going to call this regenerate mesh. And for now, we're going to leave it empty, because now that we have this set up, we can duplicate our mesh instance for each of our faces. So a cube has 6 faces, so we're going to duplicate it so we have 6 mesh instances. And now that we have this normal in our script variable, then we can name these for each of the faces we want, and we can set the normal for each of our face. So as you can see, the up here is y in Godot, so we're going to say that this face is going to be y1, and now the down is going to be -1. So the left is on the x-axis, so it's going to be -1, and the right is going to be +1, and then the front is on the z-axis. And as you can see, the front here is kind of -z, so we're going to do -z, and the back is going to be +1. So now that we've set up the basic scripts, we're going to start generating our mesh. So if we go back into our generate mesh method, we can start adding some of the variable we'll need to create the mesh. Now Godot has a very nice, easy way of creating mesh using arrays. One of the things we're going to need is to put all of those arrays inside an array. So we can create this array of arrays like so, and we can size it so that it's already going to include all of the potential mesh array we want to create. Now, of course, game engines render everything as triangles, so we'll need a way to specify those triangles. The first thing we'll need is a list of vertices for each of our triangle. So we'll create this vertex array. And this is going to be in Godot what we call a pool vector 3 array. These are special types of arrays that Godot use that are read-only and always together in memory, as opposed to regular GDScript arrays which can be dynamically typed and everything. Now, once we have the list of our arrays, we're going to have to assign some properties to all of those vertices. One of those is going to be the UV array. So we're also going to create this UV array, and the UV array is basically a coordinate inside texture, so it's going to be a vector2 array pool. And then we're going to need a normal array that's going to be used for our lighting, and this one is a vector3 pointing in the direction we want the face to be pointing, so that we can calculate the reflections and stuff like that in our material. And finally, we need a list of vertices that are going to generate those triangles. So this is going to be our index array inside our vertex array, and it's going to be a pool int array. Now that we have these arrays, we can resize them if we know how many triangles we want to generate for our planet. So this, we're going to call it the resolution. So we'll add for now a resolution variable. For example, we can call it 5. And the idea is that this is how many times we're going to split our face. So the face is one square, but we want it to have several different smaller squares. So the resolution means we're going to divide this into 5 by 5. So that means we're going to have 25 squares per faces. That means we can calculate our number of vertices by simply multiplying by the resolution times resolution. And we can calculate our number of triangle, or if you will, our number of indices, this time by multiplying the resolution -1 by the resolution -1 again, times 6, because we're going to have two triangle to make one square, and each triangle is going to have 3 vertices. So that's 2 times 3, that's 6. And then we do -1 because we are not going to be creating triangle on the outer edge. We're just going to be creating the triangle inside this outer edge. So now that we've calculated the size of our arrays, we can actually resize them by doing array.resize and num vertices, or UV array.resize num vertices, and so on. So now that we've created the data structure we're going to need to generate our mesh, we can start iterating over every square of our face and generate the triangles for it. So we're going to do this first by assigning a tri-index, and then by generating a loop that's going to loop over the resolution of our face. In his series, Lag does a great job explaining what each line of code does, but since this is exactly identical in Godot, I won't go into all the detail. The important part is that we first calculate the position of each vertices on our cube's face, and this will be determined by the normal we specified as an export here. And if you're wondering how that's going to work, well, from the normal, we can basically calculate the offset. The way it works is that we kind of have our face like this, and the normals specify which direction the face is pointing. And what we want to do is basically iterate over this A and this B axis. So we are going to calculate this A and B axis like such. And then we can use this iteration to calculate the position of each of those properties. So we're going to go x plus y times resolution, and that's going to give us an index inside our vertex array, and we can calculate the position of each of our vertices by doing something a bit like this. Now that we know where our vertex is going to go, we can add it to the vertex array. And then we need to add these vertices to each of the faces. And like I said, we're going to skip the last face because we don't want to render outside of our box. And then we're going to add those triangles. And the triangles are just pointing into the vertex array that we are creating at the same time. Now, the order we add these is important because we're using either left-hand rule or right-hand rule, which determines the direction the face is pointing. So it's important to get this right or you won't see anything. Now, in Unity, there's something called Recalculate Normal that can calculate the normals for you based on the direction of each face. Sadly, I couldn't find something that does that for us in Godot, so I had to whip up my own implementation of recalculating normals. And for this, we have to iterate over all of our triangle, and we have to do that once we've done already the first iteration, because we need all the triangles to know which direction they're facing. And what we're going to do is basically use the two edges coming out of the triangle to calculate a perpendicular vector that is going to be our normal for our face. Each of the triangle, we define an edge A, B, C that's going to form our triangle. Then we can have these be the edges from A to B or B to C or C to A, and then we can use these to calculate the cross product that's going to give us the perpendicular vector that's going to be our normal. And now we can calculate, like I said, the cross product of, for example, AB with BC to get the perpendicular vector from A or from B and so on. And this can go into our normal array at the same index as our vertex, because this is information that's going to be tied to the vertex in the vertex buffer. And finally, since we're doing a sum, it means our normals are not going to be in the range of 0 to 1, and they have to be in the range 0 to 1. So the easiest way to fix that is to just one last time, iterate over all of those, and then just normalize the length of our normal. So now, if you'll notice, we have calculated the normal array, the UV array for now we don't need. We've calculated the vertex array and the index array. So we can just put all of those inside the array of array that we created at the beginning. Now, one thing is that we don't know when this regenerate mesh is going to be called. It could be called in a thread, it could be called at any time, and sometimes Godot doesn't like it when you play around in the vertex buffers of the render pipeline while you're doing random stuff. So a good idea is to generally actually set the mesh only in a call deferred so that you're sure that at that time it's okay to update the mesh buffer. So we're just going to have a method called update mesh, and we're going to do a call deferred on this update mesh, and we can just create it right here. And we're going to pass it the buffer for rendering, like so. And this update mesh, because it's a call deferred, is going to be called during idle time on the main thread and a place where we're sure that we can generate the mesh. But all the heavy lifting we can do pretty much at any time we want. And to assign the mesh to the mesh instance node we created, we can just create the mesh using an array mesh generator. And this array mesh will just call the method add surface from arrays, and we're going to say that what we want is a mesh primitive triangles, and they're going to be found inside this arrays we passed. And finally, all we have to do is assign this mesh to the mesh attribute of our mesh instance node. And that's going to be it. Now, normally, if we call this method, we should be generating some mesh or some faces. And to test that, we're going to go back into the planet. And as you remember, the planet is the root of all planet generation. So in the ready method, what we can do is iterate over all the children. So for child, get children. And it'd be nice if we could refer to the planet mesh face as a type of resource or something, so that we can get auto-completion. So what I'm going to do is go back into planet mesh face, and I'm going to give it a class name, planet mesh face. So this way, what I can do in planet is say var face child as planet mesh face, yes. And as you can see, I get auto-completion. So now I can do face.regenerate, and it's automatically going to complete this. Now we can run this, but we're probably not going to see much because we don't have a camera set up. And I don't want to put a camera in there because, well, it really doesn't belong here. So what I'm going to do is create a new scene, and it's going to be a 3D scene. And I'm going to call this my main scene. And what I'm going to do is that I'm going to actually create the camera here, and I'm going to pull it back a little bit, maybe pull it up, and maybe orient it down a little bit. You can use the preview to see what it's going to look like. Of course, our scene is empty now, so it doesn't look like much, but we're going to add a reference to our planet, and we're going to save this as our main scene. And now if we run, we should see our cube. Of course, what we want is not a cube. Like I said, we're going to project that onto a sphere. And the way to do this is actually pretty easy, because right now what we have is basically a vector that's from the center of our planet, right? If you look at our planet here, from the center here to the corner here, and that's basically a length. So if we normalize this length, it becomes a radius, and that means everything is going to be on a unit sphere. So what we're going to do is go into the planet mesh face, and where we calculated the point on the unit cube, we're going to add a variable called point on unit sphere, and we're going to call point on unit cube dot normalized. And then all we have to do is, instead of assigning our cube to our vertex array, we're going to assign our unit sphere. And just with that, if we run our main scene again, we're going to have a nice, beautiful sphere. And as you can see, we can kind of see each of the faces here, but if we increase the resolution to say something like 50, then you can get a really nice and smooth sphere. And that's going to be it for this introduction. Thank you for watching, and see you all in my next episode. Bye!